Section 6.6, homework problem number 3. So first we're gonna use the standard algorithm to divide these two decimals. And secondly, we need to describe the standard procedure. So for example, how do we divide decimals? It's like step 1, step 2, step 3. Finally, explain in 2 different ways why the place of decimal point you described is valid. Okay, so here I did this part A here, standard deviation. So first when we set up the dividend 14.5 divided by the divisor. And the first thing we're going to do is we're going to shift the decimal points 2 places to the right in both numbers. So I should put decimal points in both numbers. And so notice that the reason we do that is because we don't want a divisor to have a decimal, because it's very difficult to answer a question how many times 2.45 goes into 14.5. 2.45 is not a whole number. It's very difficult to do that. So what we do is we're going to try to get rid of the decimal in this number right here, 2.45. And in order to do that, we know 2.45 has the tenths and hundredths. If we move the decimal point to the right 2 times, and it's going to turn that into 245. But we also have to do the same thing in the other number, 14.5, by moving the decimal point to the right 2 times. And if you run out of digits, you can add a 0. So that's going to give us 1450. And later on, in part C, we do need to explain in 2 different ways why we could move the decimal points into both numbers and then divide them to still get the same answer for the original problem. Okay, so first let's do that. Long division. So we talked about this in section 6.3, how to do long division. So first of all, and we're going to try to technically we're supposed to check how many times 245 goes into 1, but it doesn't. So how many times 245 goes into 14? It still doesn't. Goes into 145, still doesn't. So finally we have to use the whole number, 1450. So we do, does McDonald's sell burgers? So we figure out 1450 divided by 245. Roughly we can get 5 times. And how do we know that? If you don't know, you cannot see that. You have to do 1 time, 2 times, 3 times, 4 times, and eventually we'll figure out 5 times will give you a number closest to that 1450. Okay, so that's first how we figure out 5, do division. And then we're going to do multiplication, because 240 times 245 will give us, as we have to do standard algorithm, 5 times 5 is 25, 4 times 5 is 20, 20 plus 2, 22, 2 times 5 is 10, 10 plus 2 is, so that's how I got that number 1225 there. And next we're going to do subtraction, because we did division to get the quotient of 5. We did a multiplication to get 1225. Now we're going to see the remainder, and that's going to give us 225. And next B means bring down. So after subtraction, we actually get 225, but and then we, because we want to continue to, the question asks us to get the answer to the nearest 100th place. So we need at least 2 decimal places. So we're going to add a 0 and then bring that down. So repeat division, multiplication, subtraction. So we take the number 2250. Now, by the way, in the division process, the decimal point is not brought down. It's always brought up above the line. And in the process division, we don't really use the decimal point at all. Okay, so now we're going to treat this as 2250 divided by 245. So we realize, okay, and it could go in there 9 times. And again, we have to do 245 times 9. That gives us 2205. So you multiply that to get this. And after multiplication, we do subtraction. We get a 45. And because we still need at least one more decimal place, so we're going to add another 0 and then bring it down. 450, 245 only goes into 450 one time. So we put a 1 up there and write down this is 1 time of 245 and do subtraction. We got 205. And technically we can stop here, but we need one more digit in order to decide whether we need to round up to 5.92 or keep it as 5.91. So we're going to add another 0 and bring it down and repeat the process. And so 245 goes into this number 8 times. And then we got 8 times 245. That gives us 1,960. And we don't really need to continue anymore. As long as it's smaller than that, we don't really need to do subtraction because this process will go on forever. So since this digit to the right is bigger than 5, we're going to round it up to 5.92. So that's how we do part 1. Use the standard algorithm to do division. Now part B, we need to describe the standard procedure where to put decimal point. So you would say shift the decimal point 2 places to the right in both numbers. And that's part B. So part C, so we want to explain in 2 different ways why the placement of decimal point is valid. So why can we move the decimal point? Why can we shift the decimal point to the right and the same number of times? So there are 2 explanations. The first explanation is use money. So we can turn $14.50 because $1 is 100 cents. $14 is going to be 1,400 cents. So times 100, that gives us 1,450 cents. And same thing, $2.45 equals 245 cents. And notice, when in the process of turning dollars to cents, we are literally multiplying by 100. And we learned from chapter 4, I think it's 4.2, whenever we multiply a number by 100, it's like shifting the decimal point to the right or shifting the digits to the left. So that's why we, in the first step, before we did long division, we moved the decimal point to the right 2 times because that is like multiplying both numbers by 100, or in terms of money, turning both numbers from dollars to pennies. So that's the first explanation. And so original question was $14.5 contains how many $2.45, which is equivalent to solving for 1,450 cents contains how many 245 cents, because money-wise, they're equivalent. And so that's why either way will give us the same answer. But of course, we like we like to do this question better than the original one because original one has decimals. If they have the format of dollars. But if we turn it into pennies, we don't have decimal points anymore. So that's the first explanation. The second explanation is to use fractions, as we did previously. When we explained when we multiply decimals, why can we ignore the decimal points? We use the very similar way. So when we divide them, let's put them in the fractional form. So the 14.5 divided by 2.45. And we're going to multiply, because this is a fraction. It's not really it's not a real fraction, but it has a format of fraction. So we can multiply both the numerator and denominator by 100. That way, we can turn both numbers to whole numbers. Actually, we don't really need a numerator to be whole number. Sometimes you can't, but we do need the denominator to be a whole number because it's much easier to ask how many times 245 goes into a number than 2.45 goes into a number, and how many times. So, but in this case, we were able to get rid of the decimals in both numbers. And if we change the fractional form back to the division form, and that tells us 14.5 divided by 2.45 is literally equivalent to 1,450 divided by 245. So this explains the first step, why we could shift the decimal point to the right in both numbers to still get the same answer. same quotient or same remainder.